Okay, so here's the same circuit with the RC integrator in place, just a large value resistor and a relatively small value capacitor. When I clamp after the resistor, you can see that you get a steady line that goes up and down, right? No matter what time scale I use, you don't see any spikes corresponding to the PWM, so that is smooth. Now that's not being injected anywhere, that's just just being smoothed, just for the sake of it right now. If I clamp before the resistor, you can see the original thing. Let me zoom out here on the vertical axis. Alright, so you can see the pulse width modulation signals, like we'd expect, right? The issue that I'm still having is that if I clamp onto this red line, which is the clock out, come on, there we go. So now this is the clock out. I'm going to zoom in vertically, switch it back to AC mode. Here we go. My oscilloscope's pretty craptacular. Alright, you can still see spikes corresponding to the PWM right here. See that? I don't know if that's a serious issue. The PWM I'm using is a 8-bit PWM, so I guess it has a spike every 256 oscillations. So if my sensor frequency is about 10 megahertz, then that's, I don't know, 30 kilohertz or something like that. So maybe it's just not that big of an issue. Just the concern that I have is that these spikes are going to get amplified, so I don't know if it's something I should be concerned about. And here's the circuit again, if it helps. It's just PWM going through a resistor and a capacitor to ground, and it's not modulating the frequency right now. That's obviously my goal, but this is just a simple case example to show that some of the PWM junk gets in the clock out of the microcontroller.